All right, here we go. Number 7 from the homework from CEMC. Find constants a, b, c, and n that guarantee that the graph of the function defined by f of x equals that will have a vertical asymptote of x equals -3 and an oblique asymptote of y equals 2x plus 1. Well, that seems a bit challenging. We know, let's start off with the vertical asymptote. The vertical asymptote, we know that vertical asymptote happens when the bottom is equal to 0. So at x equals -3, and by the way, the top can't equal 0. We'll have to make sure of that at the end. X to the n plus c has to equal has to equal 0. Where's my back button there? Has to equal 0. But I had a brain fart because I was kind of thinking about other things at the same time. We want this has to have an oblique asymptote. Well, how do we know it's an oblique asymptote? Well, we know that the degree on the top must be exactly 1 bigger than the degree on the bottom. So that means n is 1. So we just know that x plus c has to equal 0 when x is -3. Okay, because this is just x to the 1. Since the top is squared, then the bottom must be to degree 1 to have an oblique asymptote. Alright, so we know that -3, x has to be -3, plus c has to equal 0. That means that c has to equal 3. Okay, which is probably pretty helpful. So we already know that the bottom is x to the power of 1 plus c. So just x plus 3. So we already know that the bottom is x plus 3. And the top is ax squared plus bx minus 3. Ax squared plus bx minus 3. But I also know that the oblique asymptote is 2x plus 1. So I know that when I divide, I have to get 2x plus 1. Okay, well, if I'm saying that ax squared plus bx minus 3 divided by x plus 3 equals 2x plus 1, well, I could probably just do x plus 3 times 2x plus 1. Keep in mind there will be a remainder here, though, most likely. And so let's just check this out. So we got, well, I shouldn't have said most likely, I should have said certainly, but so what could we have divided? We're going to have ax squared divided by x, and we're going to get 2x. Okay, well then a must have been 2. Okay, let's just change that to. Yeah, how am I going to do this so that it's on this way? So this a must have been a 2. So 2x squared. Okay, because 2x squared divided by x is 2x. Alright, so then when we go back the other way, we're going to have 2x squared plus 6x is going to come this way. And so these 2x squared is going to, and so we're going to have here, it's going to be b minus 6x. Okay, and now we have to divide by x again, and we're going to get 1. Okay, well then that means that b minus 6 must also be 1, because it's going to be 1x. So b minus 6 has to equal 1. So b obviously equals 1 plus 6, which is 7. Alright, let's go back to our original equation with in mind that b is 7 and c is 3. So we know that, and we know that a is 2 as well. I forgot to write that down. Here, a equals 2. So we have 2, 7, 3. So f of x equals 2x squared plus 7x, there's 3, over x to the 1 plus, and c is 3, plus 3. forgot also to write that n equals 1. Alright, we could always test this out. That shouldn't be a problem. We have a vertical asymptote at x is -3. Oh yeah, that works. See, there's x is -3. We also have an oblique asymptote at 2x plus 1. Well, here's our division. I'm going to redo it right here. 2x squared plus 7x minus 3 divided by x plus 3 will give us our oblique asymptote. 2x squared divided by x is 2x. 2x squared plus 6x. You get 1x minus 3. And this is going to be plus 1. You get x plus 3. And this is going to be -6 remainder. Alright, I'm going to graph this for fun because we should know how to graph these guys as well. So you got 2x squared plus 7x minus 3. Oh, you know what? Do I know the zeros right away on this? Alright, let's go to Desmos. Alright, what was our equation again? You got 2x squared plus 7x minus 3. 2x squared plus 7x minus 3. Alright, looks like we have a 0 at 0.386 and at -3.866. Alright, I can do that. Let's go back. Alright, so when I want to graph this guy, I know that the top has to be 0 at those two spots, which means those are going to be my two zeros. What was it, like 0.8 point something and then something over here? I don't know. And let's go back and we can see that the bottom is at -3. So -3 is over here. I'm just going to go back to Desmos to see if my number was even close here. -3.886. So that was pretty important to know because the asymptote should be on the other side. Alright, so that was at about -1 and oops. That's a disaster here. Alright. Is that like 0.866 or something? And then like so 1, 2, 3 point, let's call this -3.866 or whatever that is. At -3 we have our asymptote. Right? What do we got over here? We have a remainder of -6. If you look here, we have a remainder of -6. Okay, so that means that it's going to be a little bit less. So you're going to say this is going to be 2x squared plus 7x minus 3 over x plus 3 is actually equal to 2x plus 1 plus -6 over x plus 3. If I plug in a really big number for x, that's going to be a negative divided by a positive. It's going to be a little tiny number, but it's going to be negative. So it's going to be a little bit under the asymptote. Right, so 2x plus 1 is our asymptote. Goes like this. We have a 0 here, and I know that it has to reach that asymptote there. What goes on here? It doesn't go over the 0, so I've got to somehow get to my asymptote down here, and I've got to come. That's a single asymptote. I got to get through my 0 here, and I have to somehow change the color of my asymptote here. And I should not have made it solid either, so I should have made it like that because it's not actually part of the graph. And so this guy has to come and meet it there. Alright, there's my graph. I have a feeling that this part here does not look like this at all. I have a feeling it just kind of looks like, I don't know. I don't know what I'm doing. I do know what I'm doing, but that is not looking nice at all. Let's see what it says on Desmos. So it's just basically this guy divided by x plus 3. There you go. Let's see how close mine is to this. Let's write the asymptote in there. The asymptote was just at 2x, I think it was 2x plus 1. Let's make that a dotted line. Check that out, guys. That's perfect. It goes right along that dotted line. Let's see what it goes through at negative 3.886. Goes through at 0.386 like that. And yeah, it's pretty much what we thought. The vertical asymptote is right here. Let's check out mine. I gotta be honest, I think I like theirs nice. I think theirs is a bit nicer than mine. Alright, that's good for this video. I will do number 8 in the next video, and maybe number 9, depending on how long it takes.